Flack math! Give me some math and I'll give you some flack. Flack math!
All right, lesson 10. Okay, so this is familiar territory. We're going to solve and graph not linear equations, but inequalities. Okay, so what's an inequality? What's an example of an inequality? Like
1 is less than 2.
Yeah, 1 is less than 2. So that's an inequality. In algebra, you can say x is less than 2. But linear equations, well, I guess we're not getting there. We're just staying one-dimensional right now. Okay? So an inequality is a mathematical statement comparing quantities that are not equal. So there's 4 inequality symbols. Okay? We've got less than, greater than, less than or equal to, greater than or equal to. Okay? Now technically that greater than or equal to and less than or equal to, part of that could be equal, but we still can call it an inequality symbol. Okay? All right. So there are some properties. These are, again, some duh properties, but some of them are not quite duh-ish. So addition and subtraction, properties for inequalities. We're going to use A and B and stuff. That seems like a little too many I's, is that right? Equalities. Equalities is what I said. It's not inequalities. You can call them equalities if you want. Inequalities. Inequalities, that's right. Okay, so if A is less than B, then if you add the same weight to both sides, A plus C is still less than B plus C. Okay, so if A is less than B, this is what the balanced scale looks like, right? A is less than B, B is a little heavier. If you add the same weight to both sides, it's still the same inequality. A is still, that left side is still less than the right side, right? If you add the same weight to this scale, it's still going to look like this. Same thing with subtraction. If you take off the same weight, okay? If A is less than B and you take off the same weight, it's still going to look like this, okay? The left side is still going to be lighter than the right side.
Unless you took off all of these.
Yeah. Then it would. Yeah. Okay, so here's the multiplication and division. Now this is where it gets a little wrenchy. Like there's a multiplication, division, props of inequalities. If A is less than B and C is greater than 0, then AC is still less than BC. And A over C is less than B over C. Okay? So if you double the weight on the left side and you double the weight on the right side, this left side is still going to be less than the right side, right? And if you cut this in half and cut this in half, it's still going to look like this, okay? Now, it gets tricky when when you're multiplying by a negative number, okay? I just explained, if if you try to explain to yourself or other people what it means to multiply by a negative number, really what that means is like 3 times -2, or -2 times 3 is, instead of adding 3 2 times, you're subtracting 3 2 times. So you're kind of oppositizing everything. So if you multiply or divide by a negative number, then you basically flip the symbol. So if, this is the most important part of this lesson, A is less than B and C is less than 0, it's negative, then now AC is greater than BC and A over C is greater than B over C. It'll make more sense again when I show you some actual examples, but yes.
For the division property, they still can't be 0, right?
Right, good catch, Drew. I'm gonna give you half of your way to a free problem set. Good job. So C, disclaimer, can't be 0 on any of these. Because whenever you see a variable on the bottom, that means that bottom could change, and if it changes to 0, the universe will collapse. Okay?
No matter what we're doing?
No matter what. It's just, if you try to divide by 0.
Only in division.
Yeah. Okay.
Well, multiplication.
And all of this is true with the less than or equal to or greater than or equal to too. That's like another disclaimer at the bottom of this. Whenever you see a less than, that could be less than or equal to as well. So it's not just the strictly less than and strictly the greater than. These rules still apply to the less than or equal to and greater than or equal to. Okay, one more property. This is the transitive property. Do you guys remember transitive property of equality? If A equals B, do you guys remember the transitive property of equality? Transitive, I always think of it as a journey, logically. If A equals B and B equals C, then A equals C. So if something equals something else, but that something else equals a third thing, then that first thing is going to be equal to the third thing. Okay, well, it kind of translates similarly. If A is less than B and B is less than C, guess what? If A is less than B and B is less than C, then what can we say?
A is less than C.
Then A is less than C. Okay, do you guys remember graphing inequalities on a number line? Like filling in the dot and leaving it open at times and then shading to the left or right?
Yeah.
We're gonna do that. That's pretty easy. Sorry to waste your time with easiness. But- So how do you know when to fill in the dot and when to not?
Not filled in means that it's like less than, greater than, or equal to,
So is it,
right?
No.
so,
No.
okay.
Yeah.
I'll go ahead. Oh, so I think of it this way, so if it's like equal or like greater than or equal to, that is more ink because, or like
Yeah.
lead because there's a line under it. So
Yeah.
you like color it in. But if it's just like equal to or greater
Nice.
than, then you just, because there's like, you use less.
Yep.
Like,
So if you
that's
use
all.
more ink or lead for the symbol,
Yes.
then you're going to use more ink or lead for the graph.
I was wrong.
Okay, that's all right. So here's example 1.
I can be the guinea pig.
A, so t plus 6 is less than 7. So we're going to use the properties of inequalities to solve for t first. Solving an inequality is exactly like solving an equation. The only weird wrench in the plan, remember, is when you multiply or divide by a negative number. So right now we're not doing any of that. What do we have to do to get rid of that 6?
Subtract it.
Subtract it. So remember the properties of inequality, you can subtract the same thing and it's still less than. So we still keep that less than. So now our inequality is t is less than 1. So now we can graph that. So you don't have to be detailed. I just want to see a 1 somewhere. And then I want to see whether you're going to fill it in or leave it open. What are you going to do? Leave it open. And then where are you going to shade? To the left or to the right?
To the left. Right.
Yes. So it literally says left.
Or
Right?
points to the way that you're doing it.
Yep. So like you're going to shade that arrow or you're shading left. So if I translated this into English, it would be T is everything to the left of 1, but not including 1. Okay?
Yeah.
Or shade left of 1.
This is something that I was confused about. Couldn't you also say t is less than or equal to 0?
If you were just talking about integers, yes, but what about 1/2? You see where that? So that's why you need these circles, open circles or filled in dots.
But I guess there is numbers.
You have to worry about circle numbers if you're dealing with real numbers. Because this is all the real numbers that are less than 1. But yes, when we get into domains and say, okay, the domain is integers, so what integers are less than 1? Then you could say less than or equal to 0.
Got it.
Okay,
Couldn't
Drew?
you just flip around? 1 is greater than t.
You could
and then
say that.
The arrow trick wouldn't work anymore.
Well, 1 is still greater than all the shaded part.
Yeah, but it'd be pointing to the right.
So this represents t. So if you did t, 1 is greater than t. That's just a little bit more confusing to. So t represents the shaded part. So you could still graph this. 1 is to the right of the shaded part. So you're still shading to the left.
What you're graphing, you put on the left so that.
Yeah,
you
I
can
would.
use that.
You can always basically look at this guy on the other side of the board. So go around and so you flip it around completely. If you flip it around, flip the sign, right? So if I'm older than you, then you are younger than me. So you can say that 2 different ways. Okay, but say it with the variable on the left because that's easier to graph and it's less confusing.
Yes.
So if you end up with your variable on the right, I would flip it, but don't forget that sign flips too. So it's like you're flipping your paper over and you're looking through the paper. Okay. All right, let's do another one. A couple more and then we can be done. Step it up a notch here. Here's 1b. -2, parenthesis 4 plus b is less than or equal to 4. This is really not hard at all. It just looks hard. But remember, we're gonna still do this. We're gonna still solve this equation, but it's not an equation, it's an inequality. So we're still gonna follow the steps the same way. The only time it gets weird is when you get to this last one. So when you get to step 4, when there's that coefficient, you have to decide if you're multiplying or dividing by a negative number, okay? But don't worry about that yet. Let's just simplify this. What do you do first? Distribute. So this is -8 plus -2b is still less than or equal to 4. I haven't done anything to both sides of the equation, so I'm just simplifying so I don't have to worry about any flippage or anything like that. Okay? Second part, the simplifying is look for like terms. There's none. Third part is now our second step is if variables on both sides eliminate smaller term. There's only a variable on the left side, right? So we're going to 3. Eliminate constant term. What's the constant term on the variable side?
-8.
-8. There's 2 constant terms in the inequality,
What
right?
would happen if you
If you got rid of 4 over here, you would just make more work for yourself. You brought that over here and then you'd have to bring everything back. So it's not wrong, it's just more work. So this is +8 plus 8. So -2b is less than or equal to 12. So now you can turn on your inequality brain. Right now we are just solving an equation like we always do and keeping that inequality symbol the same. But now we have to divide by the variable's coefficient. So what do? We divide normally, but then we have to do one more thing that we don't normally have to do with equations. We're still dividing by -2 to get b by itself, but what's our final solution? Yep, you do have to, did you say flip it? Did somebody say flip it?
Could you?
You said it in your heart?
Yeah.
Yeah, so you're dividing by a negative number. In an inequality, you have to flip the sign whenever you multiply both sides or divide both sides by a negative number. Okay, so,
But you don't have to do it when it's a positive number.
right, when it's a positive coefficient, it's just like an equation. You don't have to do anything. So 12 divided by -2 is -6, but now it's not less than or equal to anymore. Now it's b is greater than or equal to -6. How do you graph this?
You shade to the right.
Shade to the right of -6, and then what do we do with -6?
Fill it in.
Fill it in because it's greater than or equal to. Good. Okay, do you guys remember this? All right, one more thing and then I'll be done with this lesson. Okay, so these are a little different. So let me just show you this example. We'll do it, and then we'll kind of try to figure out what to do with the weird answer. Okay, ready? So I'm just going to go through this quicker since we're running out of time. I'm just going to simplify this left side because parentheses are enemy of simplified, right? So we're going to distribute that. -2x plus -6 is less than -2x plus 1. So far, so good?
Yes.
Next step is if you have variables on both sides, get rid of the smaller one. Are you starting to see the conundrum?
Yeah.
Yeah.
Okay, so I can still do that if I want. Let's get rid of -2x by adding 2x. And you're left with -6 is less than 1. What happened to the variable? It disappeared. But we've run into things like this before with linear equations where the variables just disappear. But is -6 less than 1?
Yes.
Yeah.
So there's a solution to this. That means every single number that you choose for x is going to be true. So there's a graph to this. Here's what the graph looks like. You just shade the whole thing. Or you can just say all real numbers. Remember, that's the symbol for real numbers.
That's when the variable disappears.
So if the variable disappears, you're either going to get a true statement or you're going to get a false
It's
statement.
false, but you do.
So let's do that one. So here's example 2b. 4b, so you might run into this. 4b is greater than or less than 3 plus 4 times b minus 1. So I'm going to simplify this out real quick here. 4b is less than 3 plus 4b minus 4. Well, if you have variables on the both sides of the same, you don't have to subtract it. You can just do this. So now I'm left with 0 on the left side is less than 3 minus 4, which is -1. Is 0 less than -1? No. So your answer, and this would not be all real numbers, it would be no real numbers. It would be the empty set or null set.
Is that
Okay.
I think that's sad.
So there are no solutions. You could say no solutions or you could say all solutions. Depends on what curriculum you use for Algebra 2. It's different every time. Okay, and there's one more. There's compound inequalities. I'll probably go over those. We've got 6 minutes, so if you wanna, I'll go over it again on Thursday because I'm gonna go through it quickly. But you have compound inequality. So example 3 says this: 4x minus 10 is greater than or equal to -2, and 4x minus 10 is less than or equal to 10. Well, how do you solve this compound inequality? Compound inequality is saying, like, I'm between the ages of 40 and 50. I could just say I'm more than 40, or I could just say I'm less than 50.
That would be wrong.
But a compound equality gives you another condition of my age. So if I solve this, I get 4x is greater than or equal to 8. X is greater than or equal to 2. If I solve this, I get 4x is less than or equal to 20. X is less than or equal to 5. So basically, I've got this situation. X is greater than or equal to 2, and it's less than or equal to 5. How do I graph that? So here's 2, here's 5.
Will you shade in the 2 and shade in the 5?
Yeah, they're both bigger symbols, so I'm gonna shade more.
And then add the line.
Yep, and then the line goes in between. If it was like x is less than or equal to 2, or greater than or equal to 5, that's not a compound, that's called a disjunction, which means they go in opposite directions. Okay? It's impossible to say and. It can't be less than 2 and greater than 5, right? That doesn't make sense. That would be empty set. No solution. But if it was or, you would shade on both sides of those fence posts there. Okay? So find the fence post by solving the inequalities, and then determine if you're going to shade in between or shade out. Okay? So it's either an and or an or statement. Those are compound inequalities. Okay? I'm just going to show you real quick what an or statement looks like, just so you can see the difference of the two. I'm going to put it right here, awkwardly in the middle. So this is 3b. So 2x plus 1 is less than 3, or 3x minus 6 is greater than 6. So if I solve this, get rid of 1, add 6. So 2x is less than 2. So x is less than 1, or, so this is 3x is greater than 12, x is greater than 4. So here's my, it's not a compound inequality. Well, it's compound because it's two statements, but it's not they don't join together. It's not a conjunction, it's a disjunction. Okay, so I put my fence posts, 1 and 4, and they're both strict inequalities. They're not greater than or equal to or less than or equal to, so they're open circles. Now, how do I shade this? Well, just do it one at a time. Ors are a little bit easier because you're just putting two graphs on one number line. You know how to graph x is less than 1, just shade to the left. You know how to graph x is greater than 4, just shade to the right. Pretty simple, right? You're just doing two problems in one. Those or ones are a little bit easier. This is weird because you have to stop. You can't just go forever in that direction. If this was or, then you would go forever in each direction because x is greater than or equal to 2. Yeah, then you would shade the whole stinking thing. But since it's and, there's going to be a beginning and an end if there's an and statement. Okay? You guys feel like you can do that? We did a little bit of that in Algebra 1. I don't think we did anything like that in pre-algebra, but that's the gist. Okay? So this week we're just doing 9, 10, and 12. We'll teach lessons 11 and 12 on Thursday. So if you use your desk, please put it out in front of you.
Black man, give me some math and I'll give you some flack. Black man.